Complex numbers. What is the square root of a negative number? We used to say that it was impossible, but not anymore. We want to talk about the imaginary unit I, which is the complex number whose square is -1. So what that really means is if you take I squared, that equals -1. And likewise, I is equal to the square root of -1. So the key concept here is that, in general, the square root of -a is really equal to the square root of -1 times a. And that's the same as the square root of -1 times the square root of a. And since we set up here that the square root of -1 is represented by I, we can say that it's I times the square root of a. So I know in the general form it can be confusing, so let's look at an example. So the square root of -3 is really equal to the square of -1 times 3, and that equals the square root of -1 times the square root of 3. So we can actually jump from our very first part to the last in saying the square root of -3 equals I times the square root of 3. Simplifying a number using I, we need to rewrite each number using the imaginary unit I. I want you to try this first one, just like we did the example on the page before. I want you to try writing this. So pause, rewrite that number using I, and then check back with me when you're finished. Hopefully you wrote the answer I times the square root of 5. So all we're doing is we're going to take out that square root of -1 and represent that with I outside of the radical. So let's go ahead with example 2. This is going to take a little more simplifying. So we want to break this down. First, we know that we're going to take out the I, that -1, and we have the square root of 32. But we want to simplify this exactly the same way we've been simplifying. So we have I, and then inside that square root of 32, we want to break this down. We have 8 times 4, and then we want to keep breaking it down. 8 is equal to 2 times 4. 4 is equal to 2 times 2. And then one more. Our 4 is equal to 2 times 2. And then we have another 2. And our last 2. So we can group these and these. And then we can take out a 2 times a 2 times I square root of 2. So our final answer is going to be 4I times the square root of 2. Okay, now I want you to follow that model, and I want you to simplify example 3 and check back with me when you're finished. Hopefully you got a final answer of 4 times I times the square root of 3. Now if you didn't, most likely you might have missed one of the factors in your factor tree, so go back and double check your work and make sure you do not forget about that I that we pulled out in the very beginning. Next, we want to talk about what an imaginary number is. Any number written in the form a plus bi, where a and b are real numbers and b does not equal 0. Imaginary numbers and real numbers together make up the set of complex numbers. So whenever you see a number in the form a plus bi, we have the real part, we have the imaginary part that has that I with it, and together they make up the set of complex numbers. So let's talk about adding complex numbers. Adding complex numbers is very simple. We're just going to simplify. So combine like terms, and that means you want to treat the I the same as you would a variable. So we're adding these two, which means we want to combine the like terms, 5 and -2. So 5 minus 2 gives us 3. -7i and +3i. So I said treat them like variables, so you can only combine the terms that both have an I in it. So -7 plus 3 gives us a -4i, and that's your final answer. I want you to go ahead and pause, try example 2, and check back with me when you're finished. Hopefully your answer was 10 minus 8i. Next, let's talk about subtracting complex numbers. Now, our second step is going to be exactly like adding complex numbers, but we have this first step before that. We want to distribute a -1 to each term in the second set of parentheses. So this is kind of like when we added and subtracted polynomials from Algebra 1. We want to take this negative sign, this invisible -1, and distribute it to each term in the second set of parentheses. So we're going to rewrite this as 5 minus 7i, and then -1 times -2 gives us a +2. -1 times +3i gives us a -3i. Now we can go through and do step 2, which is just like adding complex numbers. Take the like terms and combine them. So our final answer should be 7 minus 10i. So go ahead and pause, try example 2, and check back with me when you're finished. Hopefully, after you distributed that -1 and then you combine like terms, you got an answer of 6 plus 10i. If you didn't, pause and check your work with mine and see where you might have made a mistake. Multiplying complex numbers. So 1, we're going to use the distributive property or FOIL when it's appropriate. And then step 2, we need to substitute -1 for every I squared that we have. Because remember, I squared, as we talked about in the notes, I squared is really the square root of -1 squared, and then those are going to cancel out, so we're left with -1. So we want to make this substitution whenever we can find it, and then lastly, simplify, just like we've been doing. So let's go ahead and work out this example. This is a case where we would use distributive property because we just have one term multiplied by a set of 2 terms. So we'll multiply this, giving us -8i, and then multiply this, which gives us +10. I times I would be I squared. So we need to take every I squared and substitute a -1. So here we have -8i, and then here we would replace that with -1. So then to simplify, this gives us -8i, +10 times -1 is -10. Then our last step is just to write this in standard form. So we put the -10, the real part, in front, and then the imaginary part comes second. And then there's our final answer. Go ahead and pause and try example 2 and check back with me when you're finished. So hopefully after you distributed and then you substituted -1 for I squared, and then you have -6i minus 3, and then your last step is to just write it in standard form with the real part first and the imaginary part second. Now, for example 3, as you see, we have 2 terms in the first parentheses and 2 terms in the second one. So we have to use the second part of it where we need to FOIL. So it's the same idea as foiling. Multiply the first terms. 1 times -2 is -2. Multiply the outside terms. So 1 times 5i is 5i. Multiply the inside terms, +12i. And then multiply the last terms, so we get a -30i squared. Okay. So then we go through, substitute -1 for any I squareds we have. We only have 1 over here, so let's go ahead and substitute that. Now, I'm going to go ahead and do this step in my head. We know that I squared is going to be -1, so -1 times -30 is going to be +30. So you can do this step in your head where you substitute the -1 as long as you do it correctly. Now our last term is to simplify and combine any like terms. So we have The real parts, -2 and 30, gives us 28. And then our imaginary parts, 5i plus 12i gives us a positive 17i, and that's our final answer. Go ahead and pause, try example 4 the same way we did example 3 using foiling, and then check back with me when you're finished. So when you FOIL, you should have 6 minus 3i plus 2i minus I squared. And when you substitute -1 for that I squared, that negative I squared, it becomes positive 1. And then when you combine your like terms and write your answer in standard form, you should get a final answer of 7 minus I. Now let's talk about a conjugate. We want to know what is a complex conjugate. Number pairs of the form a plus bi and a minus bi are called complex conjugates. So we basically want the real number to be the same, and for the imaginary part, we want them to be exactly the same except for the change in sign. One is positive and one is negative. Now the question is, when are we going to use this? So the product of complex conjugates is a real number. So look carefully. We're going to take a plus bi, a minus bi, and we're going to FOIL it. So we get a times a is a squared, a times negative bi is negative abi, bi times a is positive abi, and then positive bi times negative bi is negative b squared I squared. So first, these middle terms, these are going to cancel out. Minus abi plus abi cancels out. So we're left with a squared minus b squared I squared. Then we know that I squared always changes to -1, so when we substitute that in, this actually becomes a positive b squared. So we went from two complex conjugates, or two complex numbers, and we ended up with one real number. So we're going to use this in our next operation. We talked about addition, subtraction, and multiplication of complex numbers. So next, we're going to talk about division. How do we divide complex numbers? First step, multiply the numerator and denominator by the complex conjugate of the denominator. Then simplify by combining like terms. So you want to take the denominator, the number on the bottom, and you want to multiply the top and bottom by the conjugate. So we're going to rewrite this 3 and change the sign to plus 2i. And we're going to multiply the top and the bottom. Now we are going to end up foiling the top and bottom, so you want to make sure you put parentheses around the top and bottom as well. So let's go ahead and FOIL the top. For the top, we're going to get 6 plus 4i, and then here we get plus 15i, and then we have plus 10i squared. And then on the bottom, remember, if you flash back to what we wrote before, if you have the conjugates, what's actually going to happen is you get a squared plus b squared. So we're going to go ahead and jump to that. So this is our a squared plus b squared. So not the I part, b squared, okay? And then we're going to simplify this. On the top, we need to substitute this with -1. So again, we have 6 plus 4i plus 15i, and then -1 times positive 10 gives us -10. All over, and we'll simplify this. 3 squared is 9, 2 squared is 4. And then let's simplify the top and the bottom again. 6 minus 10 gives us a -4. Positive 4i plus 15i gives us 19i. And then on the bottom, 9 plus 4 is going to be 13. and this is our final answer. So we're really just foiling the top. You can go ahead and FOIL the bottom if you can't remember that multiplying the conjugates gives you a squared plus b squared, but you'll end up getting the exact same answer at the end. So I want you to find the conjugate of the denominator, multiply the top and bottom, and then simplify. Check back with me when you're finished and we'll see how you did. So just to let you know, I did the numerator and the denominator in different colors so that you can check your work a little easier. So when we find the conjugate of the denominator, it's going to be 1 minus I. So we need to multiply the top and the bottom by 1 minus I. And then when you FOIL the top, you get 3 minus 3i minus 4i plus 4i squared. And then on the bottom, if you use the shortcut, it'll be 1 squared plus 1 squared, that imaginary 1 that's right here in front of the I. And then remember, substitute that I squared for -1 so that this becomes -4. And then your last step, combine like terms. 3 minus 4 gives you -1. -3i minus 4i gives you -7i. And then on the bottom, 1 plus 1 gives you 2. And that is your final answer. Now let's talk about finding imaginary solutions. So this actually goes back to what we've been doing in terms of solving quadratic equations and finding the solutions, roots, x-intercepts, and zeros. However, these are going to be involving imaginary numbers. So there are actually only 2 methods you can use to solve. If it's in the form ax squared plus c equals 0, you can use the square root method to find the solutions. If it's in the form ax squared plus bx plus c equals 0, you have to use quadratic formula. Now, I know some of you like to use quadratic for everything, so if it's in this form, just remember that bx term is missing, so you need to rewrite it as ax squared plus 0x plus c equals 0, so that that 0 term is your b, and then you can plug those in to the quadratic formula. Then after you do all that work, make sure to factor out the square root of -1 so that your final answer contains I in it. You do not want to leave any negative numbers under a radical. We're not going to do any practice for that in this notes. We'll do practice in class because it only adds one extra step to what we've already been doing in regards to solving quadratic equations. So that's it, and I'll see you in class for more practice.